Hello everyone. In this video, let's continue with chapter 6 triangles. In my part 1 video, we have learnt about basic proportionality theorem, different criterions for similarity in triangles like SSSA and SAS. If you have not watched the video, part 1 link is given in the description box. Please go and check it. In this part 2 video, we will cover the following topics: ratio of area of similar triangles, ratio of perimeter of similar triangles, similarity of two triangles formed by the perpendicular drawn to the hypotenuse in a right angle triangle, Pythagoras theorem and its converse. So let's begin. Theorem 6. The ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. So we have two triangles ABC, PQR which are similar to each other. Now let's try finding the ratio of the areas of the two triangles. Area of triangle ABC by area of triangle PQR will be, area of a triangle is half into base into height. In this triangle, base is BC, height is AM. AM is the perpendicular drawn from A to the base BC. Similarly, for the next triangle, it is half into QR into PN. Both halves are cancelled, so we have it as BC by QR into AM by PN. Now, we know that triangle ABC is similar to triangle PQR. So, we can say that the corresponding angles are equal. Angle B will be equal to angle Q, and also the corresponding sides are in proportion. So, AB by PQ is equal to BC by QR is equal to AC by PR. Now let's compare the two smaller triangles ABM and PQN. So in triangle ABM and triangle PQN, we can see that angle B is equal to angle Q like we discussed here. So angle B will be angle Q, and angle AMB is equal to angle PNQ because both are 90 degrees. Angle made by the perpendicular. Angle AMB is equal to angle PNQ. Both are 90 degrees. So what criteria can we use here? By AA, angle criterion. When two angles in a triangle are equal, then we can conclude that the two triangles are similar to each other. So triangle ABM is similar to triangle PQN. So we can write that the sides corresponding to each other are in proportion. So AB by PQ is equal to BM by QN, which is equal to AM by PN. Now in this formula, AM by PN can be replaced as AB by PQ. We already have BC by QR, replacing AM by PN as AB by PQ. Now BC by QR is equal to AB by PQ. Here we have already written because the bigger triangles are similar to each other. So this is nothing but AB square by PQ square, which can also be written as BC by QR whole square, or CA by RP the whole square, because the sides are in proportion to each other. Hence, we can conclude that the ratio of the areas is equal to the square of the ratio of the corresponding sides. What about the ratio of perimeter of the similar triangles then? Here again we have two triangles ABC, PQR. Let's consider that both are similar to each other. Now, because triangle ABC is similar to triangle PQR, we can say AB by PQ is equal to BC by QR is equal to AC by PR. By law of ratio and proportion, each of this ratio will be equal to the sum of the numerators and the denominator. That is, when you have A by B is equal to P by Q, we can equate it to A plus B by B plus Q. We're just summing it up. Now, AB plus BC plus AC is nothing but perimeter of triangle ABC. Similarly, denominator is perimeter of triangle PQR. So we can conclude that the ratio of perimeter of similar triangles is equal to the ratio of their corresponding sides. Now, theorem number 7. If a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle and to each other. So we have a right angle triangle ABC where B is the right angle. Let's draw a perpendicular from vertex B to the hypotenuse. It's already drawn here. BD is the perpendicular to the hypotenuse. Now this theorem states that the two smaller triangles formed on either side of the perpendicular is similar to each other and also similar to the bigger triangle ABC. Let's consider triangle ABC and the first smaller triangle on the top, triangle ADB. Angle A is common to both the triangles, so they are same, and angle ABC is equal to angle ADB. It is 90 degrees. In the bigger triangle, ABC is 90 degrees and ADB is also 90 degrees. So by AA criterion, we can conclude triangle ABC is similar to triangle ADB. When we write similarity, we should be very particular in naming the triangle. The angles equal to each other should be written in corresponding places. A and A are common angles, so they are in the first position. And ABC is 90 degrees. Similarly, ADB is 90 degrees, so the same sequence is followed. Similarly, we can prove triangle ABC is similar to triangle BDC. From 1 and 2, we can say that triangle ADB is similar to triangle BDC, and each of them is similar to the bigger one ABC. As we have already seen, triangle ADB is similar to triangle BDC. Now from this we can write that AD by BD is equal to DB by DC. So cross multiplying both, you get BD into DB is equal to AD into DC. Just rewriting, same BD and DB are the same. It's the height of the perpendicular. So we can write it as BD square is equal to AD into DC. So this was asked in couple of multiple choice questions. So I would like you all to learn this before we proceed to the next topic. It just states that the length of the perpendicular drawn BD square is product of the two line segments here, AD into DC. Next. Theorem number 8, Pythagoras theorem. This you would have learnt in lower classes as well. Using similarity, we can prove Pythagoras theorem. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. In ABC, B is the right angle, hypotenuse is AC. So we can write AC square equal to AB square plus BC square. Like in the previous theorem, we can draw a perpendicular from B to the hypotenuse, and we can prove that the smaller triangles are similar to the right angle triangle ABC, from which we can prove the hypotenuse square is equal to AB square plus BC square. Now theorem 9 is the converse of the Pythagoras theorem. In a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. So in a triangle, if it's given AC square is equal to the sum of the squares of the other two sides, then we can conclude that the angle opposite to the side AC, that is angle B, is 90 degree. This is the converse of Pythagoras theorem. So we have seen all the 9 theorems and related concepts in this triangle chapter. Let's have a short recap of what we learnt in this part 2 video. We saw that ratio of area of similar triangles is the ratio of square of the corresponding sides. Ratio of perimeter of similar triangles is ratio of the corresponding sides. For area, it will be ratio of the square of the corresponding sides, and for perimeter, it's just the ratio of the sides. And when you have a figure like this right angle triangle with a perpendicular drawn from the right angled vertex to the hypotenuse, then these two smaller triangles are similar to each other and also to the right angle triangle ABC. Triangle ABC is similar to ADB and to triangle BDC, using which we already saw that square of the perpendicular BD square is product of AD and DC. So that's the end of this video. Hope you liked it. For MCQs from this chapter, please watch part 3 video. Link is given in the description box. Do not forget to subscribe to our channel to watch more videos on class 10 Max. Thank you and have a great day.